Hello everyone, welcome to Sangam Tutorials, Sslc-Gubbi online classes for NCERT and Cbse 10th standard for mathematics and science classes. So in the last session of light, that is in the last session we covered the power of a lens and the numericals associated with the power of the lens. So beautiful problems, some 6 problems were done. I hope you have a good grip on that. So this class is very important because we are going with numericals on concave and convex lenses. So at the end of this session you will be a master in solving numericals on lenses, right? So before going into the numerals, just we have to recall the formulas which will be associated with the lenses. So one is the lens formula, so that comes minus 1 by u plus 1 by v is equal to 1 by f. This is the lens formula, you have to remember, you have to recall this. So this is the formula we are going to use. So here we can alter the formula whenever we require according to the given data and what is to be found out, right? And next is the relation magnification, m is equal to v by u and m is equal to h dash by h. So when we combine this, we can get h dash by h is equal to v by u. So these are the formulas which are required. So very important. So based on these formulas, we are going to solve numericals now. So apart from these things, certain theoretical things also has to be remembered at this point. So one is regarding magnification. So what is the magnification of a convex lens? So here, magnification of a convex lens is said to be negative when you get a real and inverted images. Remember this, you have to please remember this. The magnification of a convex lens is negative when the image what you get is real and inverted. The magnification of a convex lens is positive when you are going to get a image which is above the principal axis, which is found above the principal axis. So that is a virtual image, virtual and erect images, right? So very simple, please remember this. So in case of a convex lens, if the image is real and inverted, then the magnification is negative. In the same case of convex lens, if the image is virtual and erect, then the magnification is positive. So in case of convex lenses, most of the ray diagrams what we have seen in the previous sessions, we get real and inverted images. So therefore magnification will be negative. In the last ray diagram, I hope you remember, when the object was kept in between the optic center and f1, I hope you remember that. So in that case we got the image to be virtual and erect. So in that case the magnification is positive. So in case of concave lenses, so usually we get only one type of image formation, that is virtual and erect. So therefore magnification of concave lenses will be always positive, right? So when the light rays are falling on the concave lens starting from infinity, they travel parallel to principal axis and they form the image on the other side of the lens. That's the only case. That case we don't discuss in numericals. We are not going to get numericals on that particular ray diagram. So here, please remember, once again I will repeat. In case of a convex lens, if the image is real and inverted, then we say that the magnification is negative. In the case of convex lens, if the image is virtual and erect, then we say that the magnification is positive. In case of concave lens, the images are always virtual and erect, therefore the magnification is positive, right? So this is the one part of that. Second part of the theory is that when we take the focal length of the lenses, that is convex lens and concave lens, when we take the focal length, in case of a convex lens, the focal length is always negative. It's always negative. I am speaking sign conventions. It's always negative. And in case of a concave lens, the focal length is always positive because image is always formed on this side of the lens, right? So where the object is kept, there itself the image is formed. So therefore focal length, when you take it, it will be always, that is negative, right? So in case of, let us remember once again, in case of a convex lens, the focal length is always positive, because if this is the lens, the focal length is taken in this direction, along the direction of the light rays, therefore focal length is positive. And in case of concave lens, focal length is negative. So image distance, that is object distance. So there you have to use sign conventions wherever required. And object height, as it is above the principal axis, it is always positive. Image, if it is a real and inverted, it will be below the principal axis, therefore it should be taken as negative. For the object distance, as in case of a convex lens, as the object is kept on this side of the lens always, therefore the object distance is always negative, and the image is formed on this side of the lens, so therefore it is always positive, because you take it in the direction of the incident light rays. So this is the sign convention you have to remember. So along with that, we have these formulas. If you are well versed in these things, numericals on lenses will be very easy for you, right? So let us get into the numericals. Okay, so we have a problem on board now. One of the first numerical we are going to take upon a convex lens, right? So a convex lens has focal length of 20 centimeters. So on convex lenses we have done a lot of ray diagrams. So this problem is connected to any one of our ray diagrams. So we should be knowing all the ray diagrams. It will be easy for us, right? So a convex lens has focal length of 20 centimeters, right? So for reference, for just the sake of understanding, I am going to draw this ray diagram for you. So this is the optic center, this is F1, this is 2F1, this is F2, and this is 2F2, right? So here a convex lens has focal length of 20 centimeters. So focal length is always taken from the optic center to the, because in a convex lens, light rays traveling parallel to the lens, they converge at a point on the principal axis. So that point is called as the principal focus, and we call it as F2. So here focal length is 20 centimeters. So this length will be 20 centimeters. This one, that is optic center to F2, will be 20 centimeters, because that is the focal length. Okay, so we'll continue the data. Focal length is equal to F is equal to 20 centimeters. Now we have to apply sign convention. Write the value of the data what we are having, and then write the sign convention for that. So as you are measuring the focal length from the optic center to F2 along the direction of the incident light rays, therefore F will be equal to plus 20 centimeters, because focal length of a convex lens is always positive, as I told you earlier. Okay, then we will go with the question now. At what distance from the lens should the object be placed? So we do not know where to place the object. So we know that the object is placed on the left side of the lens, and the image is formed on the right side of the lens. So should the object be placed so that the image is formed at 40 centimeters on other side of the lens. So that is, image is formed at 40 centimeters on the other side of the lens. So here it's very easy, it's looking very easy here. This is the focal length, which is 20 centimeters. So this distance is always equal to this. So therefore this is also equal to 20 centimeters. So 20 plus 20 is 40. So image is formed at this point. That is at a distance of 40 centimeters. So this is 40 centimeters from here to here. So here, as this is measured from the optic center to F2, that is 2F2, along the direction of the incident light rays, so therefore this 40 centimeters will be positive. So therefore this is image distance. Image distance is indicated by V, so which is equal to 40 centimeters. So we have to again check whether 40 is plus or minus. Actually 40 is plus, because we are measuring the image distance from the optic center along the direction of this incident light rays. So therefore 40 centimeter is positive. So now where we have to keep the object so that on the left side of the lens where we have to keep the object, so that the image will be formed at 40 centimeters from the lens. That's very important here. So in one of the ray diagrams, maybe in the third ray diagram, we have seen that when the object is kept at 2f1, the image is formed at 2f2, that is inverted. If the object is kept at 2f1, the image is formed at 2f2, where the size of the image is exactly equal to the size of the object. So that's according to the ray diagram. So we have to find the object distance. So before finding itself, the value of u, we have got the answer, because if this is 40 centimeters, from here to here it will be 40 centimeter itself. But in the answer, we are going to get it as minus 40 centimeters. Because why we get minus 40 centimeters? Because we are measuring something against the direction of the incident light rays. So therefore the u value what we are going to get now will be a negative minus 40 centimeters. Right. So let us get the value here. So along with this, you have to find the nature of the image. You have to find the nature of the image. Nature of the image means whether the image is inverted and real and inverted, or it is virtual and erect, or it is bigger than the size of the object or smaller than the size of the object. These things we write regarding the nature of the image. So by lens formula, very simple, by lens formula, minus 1 by u is equal to 1 by v, minus 1 by u plus 1 by v is equal to 1 by f. So this is the lens formula. We will apply all the values here. So minus 1 by u, we have to find the distance, let it be like here itself, is equal to 1 by f plus 1 by v. When it is transported to the RHS, it becomes minus 1 by v. So minus 1 by u is equal to 1 by f is 20 minus 1 by v. V value is 40. So 1 by 20 minus 1 by 40 minus 1 by u is equal to, for 20 and 40 LCM is 40. So 1 by 20 into 40 is 2 minus 1 by 40 into 40 is 1. So minus 1 by u is equal to 1 by 40. So when you take reciprocals for on both sides, so you get minus u is equal to 40. When we transfer this minus sign to RHS, or when we multiply both sides of the equation by the negative sign, so it becomes u is equal to minus 40 centimeters. So I hope you got the answer. That is the right answer according to the things what we had discussed. Right. So therefore the object should be placed at 40 centimeters. Don't write minus 40. In reality, it is 40 centimeters. Placed at 40 centimeters from the lens. Right. So now we have to write the nature of the image. So in order to write the nature of the image, you can take the help of magnification of the image. That is, m is equal to v by u. So m is equal to v value we have got here, that is 40 by u value just we have got it is minus 40. So as it gets cancelled, m is equal to minus 1. So here the minus 1, negative value of magnification, indicates that the image is real and inverted. It is real and inverted. So as m is negative, so therefore the image is real and inverted. So it's very, very important. So this is how you have to do it for 2 marks, or it may be asked for 3 marks. So this is one of the question asked in 2011 in one of the Cbse examinations. Right. Okay, so now we'll go with the second problem, which is also very important. An object 4 centimeter high, that is the height of the object or the size of the object is given, that is 4 centimeters. So this 4 centimeter is h value, right? high is placed at a distance of 27 centimeter in front of a convex lens. So you have to very particularly see what type of lens is that. So it's a convex lens. So for reference, I am going to draw a ray diagram. So if you also draw these type of rough ray diagrams while solving problems, it is very good for you. So an object 4 centimeter in height, so I will take this as the object. So I will take it as AB. So this is 4 centimeter high, is placed at a distance of 27 centimeter in front of a convex lens. So this distance is 27 centimeters. So this is 27 centimeters. So now this value is h we have got, and this value is u, that is the object distance it has given. Now of focal length 18 centimeters. So here this is the principal focus, that is f2 we will take. So this is the focal length. So this length is 18 centimeters. So focal length is 18 centimeters. So this is the value of f we have here, and focal length is 18 centimeters. Find the position, nature and size of the image formed. So it's very simple, it's looking very simple. So now let us write the data by using sign conventions. Right. First we will write the height, that is height of object. Height of object is h, which is equal to 4 centimeters. Now using sign conventions, we have to check whether this 4 centimeter is plus 4 or minus 4. Now as the object is placed above the principal axis, any measurement what we do above the principal axis is always taken as positive. So therefore it is plus 4 centimeters. Now object distance. So we will write object distance. So object distance is indicated by u. So u is equal to 27 centimeters. Now we have to apply sign conventions here. So now as the object is placed 27 centimeters away from the optic center, this is the direction of the incident light rays and you are measuring in this direction. So therefore the value of object distance u will be negative, right? So minus 27 centimeters. Next is focal length. Focal length is equal to f is equal to focal length f is equal to, so here focal length is as this is the direction of the incident light rays and you are measuring from here to here, so therefore it is taken as positive. So f is 18 centimeters and that is positive. So you have to find the position where the image is formed. Position means where the image is formed, nothing but next is nature. Nature is we have to check whether the image is that is real, inverted or virtual and erect. So and size of the image. Size means you have to find out the height of the object. That is you have to find the value of h dash. So image height. Image height is equal to h dash is equal to, you have to find out position. You are going to get it through this image distance. Image distance you are going to get that. This is image distance. We have to find out that v is equal to how much. So and nature. Nature in the sense you have to mention the whether the image is real and inverted or virtual and direct. Okay. So now we have values like u we have, f we have. So using this u and f we will find out this v, and by using u, v, h and h dash we will find out the value of h dash in the next step. Okay. So by lens formula, minus 1 by u plus 1 by v is equal to 1 by f. So we will substitute the values. So minus of 1 by u value is minus 27. So I am going to put it inside brackets, plus 1 by v. V value we have to still find it out, by 1 by f value is 18. Okay. So minus into minus is plus. So 1 by 27 plus 1 by v is equal to 1 by 18. So 1 by v is equal to 1 by 18. That is 1 by 18 we will retain that here itself. We will transpose this 1 by 27 to RHS. So that becomes minus 1 by 27. So 1 by v is equal to, for 27 and 18 LCM is 54. So 1 by 18 into 54 is maybe 3 times, minus 1 by 27 into 54 is 2 times. So 1 by V is equal to 1 by 54. So when we take reciprocal on both sides, so therefore V is equal to 54 centimeters. So here we have got V as positive. So the image is formed at a distance of somewhere here. So at a distance of 54 centimeters, distance from the optic center of the lens. So as this distance is measured, as we measure the distance of the image from the optic center of the lens along the direction of the incident light rays, therefore the value of the image distance what we have got should be positive. So therefore we have got as the positive value. So now we will find out h dash, that is height of the image. So V by U is equal to h dash by h. So this is the relationship. So we'll make the subject here. So we have to find out the image distance, that is image height. So that is h dash. We'll make h dash as the subject. So h dash into U is equal to V into h. So h dash is equal to V into h by U. So h dash is equal to V value. Already we have it. That is 54 into h. We have it. That is height of the object h as 4 centimeters into 4 by U value. So U value we already have it. That is minus 27. So minus 27. Okay. So 9 minus 3s are, and 9 6s is 54, and minus 3 1s are is minus 3, and minus 3 minus 2s is minus that is plus 6. So h dash is equal to minus 2 into 4. So h dash is equal to minus 8 centimeters. So what is the height of the object? So we have got minus 8 centimeters. So here h dash value, as you are getting this minus 8 centimeters, this value shows that the image is real and inverted, because that measurement comes below the principal axis. So since h dash is negative, so therefore image is real and inverted. So then we have to find the position, that is we have found out this. The image is formed at a distance of 54 centimeters from the lens. So image is formed at 54 centimeters from the lens. Right. So this will be the answer for this. So we have found out the position, we have found out the nature, that is real and inverted, and size is minus 8 centimeters. So therefore size of image is 8 centimeters. So you have to answer all the questions which is being asked there, because every question there carries 1 mark in that, so that you can get all the full marks for the problem, right? So this is how it goes, right? Okay, so now we'll go with the third problem, which is also very important. So here a concave lens, so lens is changed. So in the last two problems we did problems on that is convex lenses. So in this problem we have concave lens. So a concave lens of focal length 20 centimeters. So let us go with the concave lens here. So this is the concave lens. Alright, this is the principal axis, optic center. This is f1, this is 2f1, this is f2, and this is 2f2 for our reference, right? A concave lens has of focal length 20 centimeters. Now, we know that in a concave lens, the image is formed on this side, that is left side of the lens always. So therefore, focal length, that is f1 to optic center, this is 20 centimeter. So we'll write the data. So focal length is equal to f is equal to 20 centimeter. Now we have to apply the sign convention, whether it is a positive or negative. So here as the light rays, incident light rays are traveling in this direction and you are measuring something against the direction of light rays, so therefore focal length will be negative. So f is equal to minus 20 centimeter, right? Then we'll go with the problem now. A focal length 20 centimeters forms an image at a distance of 10 centimeters from the lens. So it's going to form an image 10 centimeters from the lens. So the image is maybe formed here at the center because the focal length is 20 centimeter and this is the center. So image is formed here. So this length is 10 centimeters. So this is 10 centimeters. This is the image. Because why I am writing a virtual and direct image? Because concave lenses forms virtual and direct images. So image at a distance of 10 centimeters from the lens. So we'll take the image distance. So this is image distance is equal to V is equal to 10 centimeters. So now we have to check whether by applying sign convection whether this 10 centimeter is plus 10 centimeters or minus 10 centimeters. So here, as again you are measuring something against the direction of the incident light rays in this direction, therefore 10 will be minus 10 centimeters. That is V is equal to minus 10 centimeters. Now, what is the distance of the object from the lens? Just you have to find out the object distance. So object distance is equal to U is equal to how much? So here object distance, maybe object is kept in between, anywhere in between infinity and optic center. So we do not know where it comes, but the object will be placed at somewhere here to the left side of the lens. So the value what we are going to get as object distance should be negative. That's a little bit of confirmation. It should be a negative value, right? So let's see. So by lens formula, minus 1 by U plus 1 by V is equal to 1 by F. So minus of 1 by U value we have to find out, okay, plus 1 by V value is minus 10. So we will put this minus 10 inside brackets is equal to 1 by F is minus 20. So this becomes minus 20, okay. So minus 1 by U plus into minus is minus 1 by 10 is equal to minus 1 by 20. You can just raise the negative sign to the numerator. So minus 1 by U is equal to minus 1 by 20 plus 1 by 10, because minus 1 by 10 after transposing to the RHS it is going to become plus 1 by 10. So minus 1 by U is equal to, for 20 and 10 LCM is 20 again, minus 1 by 20 into 20 is minus 1 plus 1 by 10 into 20 is, that is 2. So minus 1 by U is equal to minus 1 plus 2 is 1 by 20. So when we take reciprocal on both sides, so minus U is equal to 20. So U is equal to minus 20 centimeters. So where should be the object placed in front of the lens? The object has to be placed at a distance of 20 centimeters from the lens. So you have to write the statement. So therefore the object should be placed at a distance of 20 centimeters from lens. Right. So this is how it goes. I hope you are feeling easy. Right. Okay, we'll go with the next problem, that is the fourth problem. A needle placed 45 centimeters from a lens. So lens is a secret. We do not know which lens is being used here, whether it is a concave lens or it is a convex lens. We do not know it. By reading the question, by understanding the data, we will decide whether it is a convex lens or a concave lens, right? So a needle placed 45 centimeters in front of a lens forms an image on a screen placed 90 centimeters on other side of the lens. So this happens in which lens? Concave it cannot be, because the object where it is on the same side the image is formed in a concave lens. So in a convex lens these things happen. So if the object is placed here, the image will be formed here. So if the object is kept at okay, if you consider this as a lens, if the object is kept at 45 centimeters from here, the image is formed at 90 centimeters on the other side of the lens. So this will happen only in the case of a convex lens. So therefore we can easily decide this lens is a convex lens. So we will go with the solution. So it is a convex lens. It is a convex lens. Now we will go with the things. A needle placed 45 centimeters away from the lens. So needle is the object here. It is placed 45 centimeters from the lens. So 45 centimeters, if this is the lens, it is placed 45 centimeters on this side. So therefore this becomes the object distance. So we write the object distance. Object distance is equal to U is equal to that is 45 centimeters. So by applying sign convection we have to decide whether it is negative or positive. So this is the convex lens. Here the object is placed. So it is measured from the lens to the object in the direction opposite to that of the incident light rays. So therefore U will be negative, right? So here from a lens forms an image on a screen placed 90 centimeters on the other side of the lens. So therefore image distance will take is equal to V is equal to 90 centimeters. So 90 centimeters should be taken as positive or negative. It should be taken as positive, because if this is the lens, image is formed somewhere here at the deep, that is 90 centimeters. You are measuring from here to here along the direction of the incident light rays. So therefore it is plus 90 centimeters, right? On the other side of the lens. Okay. Identify the type of lens. So it's already done. It's a convex lens. Find focal length. You have to find the focal length. Okay. So focal length is equal to F is equal to how much? Don't apply any signs. And power of the lens. Okay. Oh, you have to also find the power of the lens. So power P is equal to how much? Power P is equal to how much? And find the size of the image if needle is 5 centimeter in height. Oh, okay. So this is the convex lens. Image, that is object is 5 centimeter in height. That is needle is 5 centimeter in height. Then find out the size of the image. So object height. Object height is equal to H is equal to 5 centimeters. So if you apply sign convection, it will be positive because it's above the principal axis. So you have to find the image height. Image height is equal to H dash is equal to question mark. So image height, it should be negative. So we'll first find out the focal length. So minus 1 by U plus 1 by V is equal to 1 by F. Very simple. Minus 1 by U is minus 45. So minus 45, please keep it inside brackets, plus 1 by V. So V is 90 centimeters. 90 is equal to 1 by F. So minus into minus is plus. So 1 by 45 plus 1 by 90 is equal to 1 by F. So 90 becomes the LCM here. 1 by 45 into 90 is 2, plus 1 by 90 into 90 is 1, which is equal to 1 by F. So 2 plus 1 is 3 by 90 is equal to 1 by F. 3 1 times, 3 30 times. So 1 by F is equal to 1 by 30. So therefore F is equal to 30 centimeters. So focal length we are getting positive. So focal length getting positive means it's the lens what we are using is a convex lens. So we have found out the focal length, it's ready, and you have to find the power. So here, before finding the power of the lens, we have to check whether the focal length of the given lens is in centimeters or in meters. So this 30 is in centimeters, focal length is in 30 that is centimeters. We have to convert this into meters and then we have to find out the power. So P is equal to 100 by F. This is the formula, direct formula. Don't use, don't convert centimeter into meter what we had done in the in case of power of the lens problems in the previous session. So directly you can go with this. So P is equal to 100 by F is 30. 0, 0 cancels. So P is equal to 10 by 3. Okay, it becomes a recurring decimal. So P is equal to, it is 3.33, it continues. So 3.33 diopters. So we can just take 2 decimal places and stop it. So power of the lens is 3.33 diopters. So find the size of the image if needle is 5 cm in height. So you have to find the size of the image. So we have U value, we have V value, we have H value, we have to find out H dash. So relation between U, V, H and H dash is given by V by U is equal to H dash by H. So I have to find out H dash. So H dash is equal to, or H dash into U is equal to V into H. So H dash is equal to V into H by U. So H dash is equal to V value, it's ready, that is 90 into H value, that is 5 centimeters, by U value, that is minus 45. So minus 45 ones are minus 45 minus 2s are. So H dash is equal to minus 2 into 5. So H dash is equal to minus 10 centimeters. So here the H dash is minus 10 centimeter indicates that the image is real and inverted. Okay, so this is, maybe this can be asked for 4 marks because power of the lens is also included in this, right? So I hope you enjoyed the entire session today. So in tomorrow's session we'll be going with still more problems on numericals on lenses. Very important. Please watch the video again and again. Subscribe the channel. Put a like button on it. Right, until the next section, practice all the problems, get a good hold on it, understand everything before getting into the problem directly, understand the data what it is given, put all those datas in the ray diagram if you want. It is better because if you draw a ray diagram for the given problem, you will be more perfect because no confusions will be there, no silly mistakes can be done. So here you can reach to the answer very easily and perfectly, right? So stay home, stay safe and keep learning. Thank you.